All right, we're back. We're going to be on page 6 of notes 14. We're talking about the logistic differential equation, and we pretty much know what we need to know at this point. We're just doing some practice. So you might be able to breeze through this page, and then you could just like scroll to the end and see how your answers compare. I don't know. I'm going to do them anyway, so let's see. We have a differential equation. It's already written the way we need it to be because of the 1. So that's you're always looking for that. That's the key to making everything that we memorized actually run the way it's supposed to. So I need to calculate A. So what do we know here? We know that P of 0 is going to be 200. That's given. We can see that K is 0.03. We can see that L is 2000. So A is going to be the limit minus the initial over the initial. So that's, I don't know what that is, 1800 over 200, so 9. It's always 9. It's not actually always 9, but like it is frequently 9. So P of t is going to be the limit over 1 plus 9 e to the negative 0.03. Ew, 3. 3s are hard. Will I ever get better at that? I don't know. That's it. That's the end. Right? So if you know what you're doing, logistics pretty quick. And I hope I got that right, because that's one of those things where you just sound like a dummy if you got that wrong, but you're claiming that it was easy. So let's see. This one's also kind of written the way that I want it to, except I don't like that. I don't like that. Basically, I don't like decimals in these, even though I'm sure in the real world that's like the most common way. Let's rewrite this. So this is 5 over 100, say 1 over 20, 1 minus P over, all right, so it'd be over 10, 100, 1000. I actually have a lot of trouble with that, like converting those decimals. I know that I shouldn't, but I just do. And I think there's kind of nothing I can do about it. So we know, it's like basically all the same information, right? So we know P of 0 is 300. We know that K is 1 over 20. And we know that L is going to be 1000. So we have to calculate A. It turns out maybe calculating A is the hardest part of this. So it's 1000 minus 300 over 300. So 700 over 300, so 7/3. And P of t is, the limit. So 1000 over 1 plus A e to the negative 1 over 20 t. There you go. Okay, let's see. A population of bacteria grows logistically. That's very common because bacteria, as I've mentioned previously, people are pretty casual about the murder of bacteria or the growth of bacteria. Like we don't seem to mind that as much as we do deer and things. Deer and rabbits are common applications. Population of bacteria grows logistically. Suppose the initial population is 3, so that's P of 0 is 3 milligrams, I guess. Is that a reasonable way of measuring bacteria? I have no idea. I am sure that I took this problem from somewhere else. The carrying capacity is 100, so that's L. So we could calculate A. Is going to be 100 minus 3 over 3, so 97 over 3. 97 is not a multiple of 3, so 97 over 3. And then the growth parameter, so that's K. K is 0.2 per hour. You can tell the growth, you can tell what K is, like find the thing that has the weirdest units, and it's probably what K is. So it's like 0.2 per hour. You're gonna multiply by hours, and it'll just give you 0.2. 0.2 times the number of hours, but whatever. Find the differential equation satisfied. Okay, so that's gonna be dP dt is K, which is something, 0.2 P 1 minus P over the limit, which is 100. There you go. Find the population. So that's going to be P of t. We already calculated A, so it's the limit over 1 plus A. We got 97 over 3 e to the negative K, which is 0.2 t. And there you go. When will the population reach 90? When will it reach 200? Gross. All right. Algebra. So 90 equals 100 over 1 plus. This is not a pleasant little algebra problem, I think. 1 plus 97 thirds e to the negative 0.2t. It's going to be 10 ninths. So if I subtract 1, I get, I don't know what direction I'm working in here. 97 thirds e to the negative point. You could probably use a calculator. I don't know that I personally care. Multiply by 3, you get 1/3, divide by 90. Oh my god. Okay, so if I multiply by 3, I get 1/3, and then I have to divide by 97, so that's 291. 1 over 291. Okay, so I think it's e to the negative 0.2t is 1 over 209. I wonder if my microphone is doing a good job of blocking out all the like crazy sounds around me. It's like there's somebody taking a shower next door. There's also like someone doing some yard work out there. There's always someone doing yard work. I don't know. So hopefully it is. Where did I get 291? 3 times 90, and then 3 times 7. So 270 plus 21. Seems good. I'm going to take the natural log, divide by negative 0.2, and flip the 291. And I'm going to get that t is the natural log of 291 over 0.2. That's my answer to that. And then 200 milligrams. When will it reach 2? Does it reach 200? Can it reach 200? 200 is more than the limit, and the initial value is less. So I think this is a trick. I'm going to say this is a trick question. Then I'm going to try it on the calculator. And if there is a time, I feel like that time will be negative, is my thought. So 200 is greater than 100, which is the limit. Therefore, never reaches this. I don't know. I wasn't expecting there to be a trick question. Honestly, usually I just have people like work on these on their own. We never go over them. It's been years since I solved any of these problems, like on this page. I'm going to switch to the calculator and just see what it has to say about this issue. So what's my P of t? Well, let's get a calculator page. P of t colon equals 100 over 1 plus 97 over 3 e to the negative 0.2t. So I always type exp because it's easier for me than using the button. For you, it's probably easier to use the button. It's almost definitely easier. Also, you should be using your calculator all the time, so pressing all the buttons should be like really fast. That's the idea. All right, so if I solve P of t, let's do the previous one. Solve P of t equals 90 for t. And then, so that decimal that's in P of t is what's giving me that approximation. If I change this to negative 1/5, 1/5, and then do it again, it should give me the exact value. So it gives me 5. Oh yeah, because I got natural log of 291 over 1/5, which is 5 times the natural log of that. So that worked. 200, let's see what you got for us. False, as predicted. Nice. I solved it approximately and got false, and then I tried to solve it exactly and got false again. That's why I did that twice. Never gonna get there, because if you start below the carrying capacity, you can't suddenly get over the carrying capacity. It's never gonna happen. That's like the premise behind a carrying capacity. All right, let's try one more. And then we're done with this page. All right, so the issue, as with many things in math, is 1, the number 1. This is not the number 1, so this is not written the way we want it to be, but we can rewrite it. So y of t is divide everything you see by 10. 55 2e to the negative 0.1t. All right, now we're good to go. So then the limit. Well, actually, I didn't need to do that to find the limit. I don't know why I did. I did that because it should look the way it should look, let's say. But I didn't need to do that to actually find the limit of y of t. Is definitely just 55. Where am I writing this? 55. So then write the differential equation for dy dt in terms of y. All right, dy dt is, so I need to know a couple of things. So the limit is definitely 55. K is definitely 0.1, because remember, it's e to the negative kt, so it's 0.1, not negative 0.1. I need to know y of 0 so that I can calculate. Well, actually, what am I trying to calculate? I have k, I have l. I don't need to calculate anything. It's like I was trying to solve the differential equation by looking at the solution to the differential equation. So it's going to be 0.1 y, 1 minus y over the limit is 55. And there you go. All right. That's another page down. Good practice problems. Hope you found this helpful. I will see you in the next video where we're just going to keep doing more. So see you there.